Okay. Hello guys. We are from mycujoo. Jason and I. We are going to present a little bit about like how we do deployments at mycujoo. We're a. Let's follow the agenda a little bit. I was a little confused. Who are we? Well, this is Jason. He's a Devops engineer at mycujoo, and my name is Stefan Hoogendijk. I started at mycujoo 2 years ago. We're kind of a fresh startup. I was one of the first people to get hired there. I've been put in charge of the IT operations at mycujoo, and recently been joined by Jason as our second hire. You can find us on GitHub and on Twitter. Interested in getting in touch with us. What is mycujoo? mycujoo is a global football live streaming platform. We do mainly first and second division football content. So for the clubs that don't have their exposure with their fans just yet and looking to improve it, so they're streaming their matches and their like trainings and interviews and etc. via mycujoo. We do also like a VOD upload, so if you have like an interview, we arrange that, and we provide them also with help on how to do broadcasting. So we developed iOS and Android apps to do broadcasting, so you can just broadcast a football match with your phone onto our platform, and we help them, setting up like professional things as well with our partners in Japan, Revo, and some others. We're active in 60 countries and spanning over 4 continents. So obviously that takes a lot of software to run. So first we went to Google Cloud and we spun up a bunch of machines there, and that turned into managed instance groups that turned into a huge mess with console and TWAM proxy to do highly available Redis, and everything needed to be highly available, everything needed to be scalable. A lot of Ansible code, a lot of Terraform configuration, and it was all a huge mess. We tried to simplify that. We spun up our first container engine cluster of Kubernetes, and we started to roll that out, and suddenly we found ourselves in a huge mess of YAML configurations, right? So we wanted to give it a little bit more structure, and we had some dependencies back from our legacy application. So we used Vault to store the secrets because Vault is awesome. I don't know if anybody here used it, but I like it. And we were using Distelli before. I don't know if anybody knows Distelli, but it sucked really bad. At least in our opinion, we found it quite difficult to deal with, and it was very buggy. So we switched to CircleCI, but to do our CI and CD. So we needed a tool, an easy tool that worked well in kind of any CI CD environments that people can interact with via the command line as well. And it played obviously well with our legacy infrastructure. It should be easy and straightforward for developers to use, so just simple commands, no-brainers basically, to do rollbacks and deployments, etc. So it cleaned up quite a bit. So it's a bit of an opinionated tool, so you can use it. It's open source. It's on our GitHub. Would be actually good to have a link in here to the GitHub repository, but we can send it out, no problem. So it uses Vault to source its secrets. So all our secrets are basically sourced from Vault and are put into Kubernetes secrets that are translated like on the fly via templating. The templating is just like a straightforward console template which uses Go template underneath. The configuration is fully just YAML based, very easy, very straightforward. We needed to deploy on like different clusters for production, for development, staging, etc. So they use 2 different Google Cloud projects, and the releases are all based on the Git branch and the hash of the commit. So that's my part actually, and Jason will take over from here and will actually show the tool and what it can do.
Hey. So before I start, I'm just curious, because I know the first talk was also about Kubernetes, and I got to be honest, this is going to be pretty Kubernetes heavy as well. So how many people have ever worked with Kubernetes before? Oh, okay. And how many of you work with Kubernetes daily? Small group. Okay. So I'm going to try and go slowly and be clear and try and show what I'm doing quite clearly and explain some of the concepts. But if I gloss over a term or something which is not clear, please stop me so I can explain or correct myself. So like Stefan mentioned, we needed a tool which can deploy our code, and we also wanted it to be able to build and deploy our code in sort of a CI agnostic kind of way. A lot of our configuration previously was sort of a collection of bash scripts tied up with a lot of specific CircleCI configuration, which is nice. The CircleCI YAML is pretty easy to work with, but it's also completely tied to CircleCI. And the way it was mixed up with some bash made it really kind of confusing for new people to start working with, and also impossible if we wanted to try and port anywhere else. So the goal of this tool was to be able to have a sort of one way of doing a deployment, whether it's a manual deployment or a manual rollback, so that developers can kind of do deployments from their local. I'll explain about this a little bit later. As well as doing rollbacks in the case of failures. And that be the exact same commands that are coded into our CI configuration, so that the CI looks exactly the same as the commands that you would actually do as a human. So I'm going to show you how it works a little bit. I also have Visual Studio Code running, but unfortunately no cool themes, just the stock. I'm really dropped the ball on that. So I'm going to show you a very simple application. This is my favorite new application. All it does is return hello world, but I'm really, really proud of it. And but the other thing that was really important to us is we wanted to have all of our code run entirely in Docker containers. We wanted to make sure that when we do builds, oh sorry, I'll make it bigger. I realize it's probably really hard to see for people in the back. Tell me when to stop, I'll just keep going. Oh god, too far.
That's big enough.
One more. Okay.
One more smaller, one more bigger?
Bigger.
Okay.
There we go.
Perfect. All right. So, now can you see why I'm proud of it? Okay. So, so we also wanted to make sure that our code always runs inside Docker containers. So to escape from a situation where we're doing a build outside of a container and then just dumping something in the container, to make sure that we do our builds and our tests in the same place that the same kind of environment where we run. So to show you this, I'm not even going to attempt to run this on my local. I'm going to go directly to building and running a Docker container. So I have a Docker file here as well. How many people are familiar with Docker? Okay, that makes me feel a little bit better. All right. Okay, so then you might be a little bit familiar with this at least. Very simple. I'm just taking the node image. I'm adding curl so that we can run tests inside the container itself, and running npm install. And our package.json is really simple. If you're not familiar with Node, nice job. But we're basically just installing Express, the framework that will serve this. So this is really simple. I'm just going to go Docker build, and we're going to call this project hello. Really, really simple and easy. Docker's a little bit slow on the Mac because the VM thing, but it does start eventually. So I'm making this build. Again, we're doing everything inside Docker, and now when I want to run it, if I want to run my test to make sure it actually worked, I can do Docker run, and I'll clean it up afterwards. And let's just run. Well, first I'm going to start the container, and I'll open up the port so that we can actually curl it. So I'm going to curl. That's not a good sign.
I don't think it's like that.
I'm giving away some of the future here by doing this. There it is. No? All right, let me just do a new terminal. It's a Kubernetes thing. So let me build again. So effectively, if we want to test, if we have some tests that we want to run, in this case, I have a very simple test suite. I'm going to curl to make sure that the application can actually start. It sounds trivial, but it does prevent cases which we had come across before, where because there's no compile step, you end up with a potential problem of it runs on my machine, right, which everyone I'm sure has heard before. But also you can push syntax errors and not even realize that they're the case, because nothing happens during the Docker build step to actually check that the application will start. Right? The build step is, as you saw, just copying the source code into the image. So before we push it to the remote, as a responsible developer, I'm going to test to make sure it actually runs. I'm going to try this again. I know it didn't work before. There we go. Yay, it's working. It's such an amazing project. But just for explicitness, I'm going to actually run this I'm going to run this command inside the container. So I'm going to do docker exec, the name of the container, curl, localhost, and it works there as well. So that's having the container curl itself to make sure everything's working. So now that, as a developer, now that I'm good, what I can do is I can go into my Kubernetes configuration, and I'll just show you my amazing Kubernetes configuration. If you're not familiar with Kubernetes, try and ignore all of the label, and focus on the fact that this part is a deployment. So that says how much of the application we're going to be running. One replica, and my image is here. I have a service which will expose this so that I can actually reach it on some port. I'm going to translate port 3000 to port 80. And then I have an ingress, which will allow me to give a rule so that all the incoming traffic into the cluster can be sorted based on host. So I've said for stuff that matches this host, route it to this service. And then that service is this one here. This service has a selector, which is app is hello, and that will get routed into my deployment. So it all goes back in the other direction. Traffic comes in for a specific host, header, that gets routed into my service, the port gets translated, and then it ends up against my application. So this all works really, really well until I need to change the name of the application. And look at how many places I would have to change where it says hello. And imagine how many different files this can be, because obviously in this I'm using one file with the YAML kind of document delimiter to make it easier to show to you. But imagine if this is spread out over 3, 4, 7, 20 different files. Now I'm changing the same name in tons of different places. And it's not necessarily just the name. The other kind of key part of the way our infrastructure is structured is that all of our configuration, for the most part, is environment variables. So if I need to pass through different parts of environment to this, I'm changing things in lots of different places. And it can be a real, real mess to manage environment variables all over the place. So, a better way. So the way we structure things with the kube-deploy tool is that instead of all of these hard-coded values in this Kubernetes configuration, instead what we're going to do is we're going to have a little directory. In this case, I'm going to separate them out into files. I could have done that in the previous way as well. It's just easier to show you. And instead of hard-coding any of those values, I'm going to do something very similar to what we saw in the previous talk. I'm going to add placeholders, right? Really simple. These are based on the syntax that console template uses. So slightly more advanced than sed, but the same idea. And I'm just going to put in some of these placeholders. So I've got app name, replica count, KD is the prefix for the tool that we're using, kube-deploy. Things like namespace, and then the other interesting one is in the ingress, I'm going to add the domain that I expect this to listen on. So, but to template these out, we need these to come from somewhere. And I want to be able to describe the values where these come from as code in a way, as sort of declarative. So we place all this kind of configuration inside a file called deploy.yaml. Could have called it anything. It's just what we call it, which describes how we're going to template out all of this configuration. So I've said here, so if I scroll down to the globals, I've said, okay, well, my namespace is going to be, and then this is copied out from the tool. So that's going to directly map to the branch name. If you remember, one of our other things that we said is that we do our deployments based on source control branches. So this is very straightforward. If I'm on the production branch, I want to deploy into the production namespace in the production environment. And I want all of my environment variables to be related to running things in production. If I'm going to deploy to staging, I'm going to deploy from the master branch, which is kind of how we do things. Everything that gets merged into master gets deployed immediately to our staging environment, where we can kind of test it in a production-like way. Anything else I want to deploy into the dev environment. It's sort of a sandbox. I don't really care. What it means is every branch that every developer pushes to will always be deployed. So we can find out immediately if any developer breaks the build. Because if they push source code that doesn't build, we're going to attempt to build and deploy it. And if it doesn't work, we find out then. We don't have to wait until we merge it into master or try and roll it out to find that out. So, and then I've got my image, which is going to be generated by our tool kube-deploy. And then I have some variables which differ for each branch, right? So those were the globals. But for the different branches, well, replicas are how many copies of the different containers I'm going to, well, pods, containers, I'm going to be spinning up. For dev, I only want to spin up one because really I just care whether it will start up at all. And if someone's going to test it, it's going to be the developer that's working on that feature for the most part. For master, well, there might be a couple people testing, but 2 should be fine just to make sure that they can both, multiple replicas can come up in parallel for features that require concurrency. And then production, I want to make sure this thing is rock solid, so I'm going to throw 10 copies at it. And you can also see that the domain differs. So in master, I'm going to subdomain it with staging. And on dev, I'm going to do .dev for our namespace. I'm going to do the project, and then I'm going to do the branch name. So this means that for every branch, we're going to have a unique DNS record, so that we can every developer can just make a simple request to the application for their branch.
And just one side note about like the versioning and the JSON. Well, and we internally use Cube Lego. I think it's called Certificate Manager now or something, and external DNS. So these domains, when used in the ingress, and this is like our use case, is that automatically register a domain name with external DNS, for example.
I'll show that.
Yeah.
So I have my ingress rule. Remember I said domain is kind of an interesting one to be templating. Actually, I don't have it in this example here, but in our production code, we also have a configuration that will automatically generate an SSL certificate and automatically create a record in Cloudflare. So that's all done programmatically. All we have to do is push this, basically like create this ingress object in our cluster, and we automatically get the SSL certificate and the DNS record. Anyway, so that's how we do the templating. The other interesting part is how we do the building, because remember that part where I had to start the container, curl, make sure it worked. That was a bit of legwork, and developers are so lazy, they're never going to do that. I know this is the point of automated test suites, but this is Node.js. Nobody's writing automated test suites. And even if you are, like that's a step that you have to ask the developers to do or set up as part of Git hooks. And there are ways around all those things. And we want to make sure that we kind of have a last point of entry, that we don't end up deploying something that doesn't start, doesn't compile, that kind of thing. So in this same configuration file, we can define some tests. So I'm going to say I want to run a test inside the container that I'm testing. I want to start it in the background so I can test against it. And all I'm going to do is give it some time to start and then curl. And this is going to run inside that same cluster. Or sorry, inside that same container. So I'm going to use this tool now. Kube-deploy build. So I'm just going to, while it starts building, I'm just going to show the first thing is how we do the naming convention. Because versioning is super difficult, especially for Docker, which effectively gives you the project name and then one identifier, the tag. And we need that to both be human readable and also sufficiently unique. So we combine a few things. So I've got my repository. This is the feature that I'm going to be working on, which I'm going to show you how I'm going to deploy first, and then I'm going to work on this feature and then deploy again. And this is the head git hash, right? This is where I am right now. So we add all those up, and we end up with version identifier, the branch name, and the git hash, which in combination gives us something that's human readable and also sufficiently unique. The sufficiently unique part is important because it allows us to roll back to any point in history without having to do a build again, because we already did that build once, and that is going to live on our repository forever. So now I'm just going to scroll through. You can see in subcommands, it's effectively just running my Docker build step. In fact, it's directly doing that because it's just using the cache. It's going to tag it, and it's going to start running this test. So it ran the test, got the response, stopped, removed the container. We're all good. All the tests pass, so now I'm going to proceed. I'm going to push this to the remote. For CI and CD, we can automate this process and say, if it passes the test, push anyway, just go for it. So that this can run automatically without any human intervention. So now we're pushed, which is good. Now I'm actually going to switch over to, I've got a Kubernetes cluster running on my laptop locally so that I can demonstrate this. So I'm going to switch over to that. This is the problem I was having earlier, is I was, I can't curl against this because this is inside of VM. So now, there we go, I see all the Kubernetes things. So now what I can do is I'm going to start a rollout. I'm going to roll this out into my cluster. So first I'm going to just check where I am. So I'm going to default, I'm going to switch. This is a tool for getting around Kubernetes namespaces. So I'm going to switch. Oh, let me just check I'm on the right clusters. Yep.
What's that name?
KNS. The full name is kubens. KNS is just a shortcut. It's a really, really awesome tool that just, it basically, all of the like kubectl config, set context, all that stuff, it makes that really easy. There's two. There's kubectx for changing context, and then kubens for changing namespaces.
So what like doing git checkout.
Yeah, it's makes it as simple as that, which as opposed to, I think it's kubectl config current context, I think is the other way.
Yeah.
Right, which is just so verbose. Confusing. Yeah, and what does it mean? Yeah, and trying to remember whether it's kubectl context current config, and anyway. So I'm going to check I'm here. I'm going to switch over to the development namespace. Now remember I said for things on the production branch, they're going to deploy into our production environment. Well, that's just our production namespace in this cluster. Same with master is going to deploy into our staging namespace. And because I'm working on a new feature, that's going to deploy into our development namespace. I'm going to check that I don't have any of my practice stuff left over. Good, okay.
So within that development namespace, you could deploy several things in parallel for different domains.
Yes. You can.
I thought it was kind of cool, actually.
Yeah, you can deploy as much as you want, really. I'm going to show you exactly how it works and how we handle, because how we handle domains relates to, and deployments relates to how we handle roll forward and roll back. So I'm going to start a rollout. What did I do? kubectl. I meant to do kube-deploy. What's that one I wrote? Okay. So the first thing it's going to do is check to see if the Docker image exists, which is it's basically going to try and pull. because there's not really that reliable a way to check if a Docker image exists that will work for all the different providers. So in my top level here, I've said Docker repository, and I've given, they're both just mycujoo, which is our account on Docker Hub. For our actual production work, we use the GCR, the Google Container Registry, and we actually have different. So we have different repositories for one for development and one for production. So these actually normally differ. So for that, basically what we do is we have a registry root, which is like this, and then we would have something like. So this will then oh, I got that backwards. That's just for fun. But basically then any builds that are for the master branch and the production branch will automatically go to the production repository name, and any builds that it knows are going to be against the development environment will automatically build against the development name. Obviously this matters because when you build and tag a Docker image, you're associating with the place where it's going to go. Okay, so going back to what we did here. So the first step, check to see if the Docker image exists. It already did, so we're just going to continue using that. That's basically checking to see if the Docker image exists on the remote for this git hash, right? Because we're using the hash as the unique identifier. So that's basically a way of saying if the exact image that would exist if I built right now, does that exist there? It's not technically true because I could be changing something in the source that I haven't committed, right? I could have a dirty working tree. So on production and master, we actually block that. So if you can't build and you can't roll out if your working tree is dirty on the master or production branch. Feature branches we don't care about as much, but that's to prevent you ending up pushing something which differs from that place that it thinks you are in the source tree. So we're going to continue just using that existing image. In case I'm running this on a deploy server where multiple people access the same server, this kind of comes to maybe how you would handle security. So one of the ways we want to handle security, because the prerequisites for being able to run this are access to Vault in case you use Vault secrets like we do, which is a big one, and access to the Kubernetes cluster to be able to create those Kubernetes objects. We don't necessarily want to give that to all developers. For some developers, yeah, they have their own access to Vault and they have their own access to the Kubernetes cluster. For developers that don't have access to those things, we provision one server and we give it a Vault token and we give it direct access to the Kubernetes cluster. So we kind of sandbox a place where the developers can go to use sort of central credentials for that. So if that's the case, we write a lock file so that no two developers can end up rolling out from the same box at the same time. And then we're going to go through all those templates that were in the Kubernetes directory, and we're going to generate the YAML. It's already deleted it, but it's going to put that in a temp file. So if we wanted to, we can persist that for debugging to check and see, for example, if there's a syntax error in our YAML and we want to find out what the actual produced YAML was going to be, we can just dump that out and inspect it ourselves. So we've created the deployment, the ingress, and the service, and we're rolling out. So the first thing it's going to do is roll out one of the replicas. Now in this case I am only rolling out one replica, but in the case where I might be rolling out 10 or 100, we're going to roll out one first, just to make sure the container can start, the pod can start, and in case we are using health checks, which is a feature that Kubernetes can kind of check the service itself to make sure it's running properly, to make sure that it's passed all of its health checks. It is possible that if it doesn't pass all the health checks, either it'll crash and the kube-deploy tool will quit, or the kube-deploy tool will just hang and wait forever, which also tells you there's a problem, and then you have to kind of go and intervene.
Question.
Yeah.
It's now the log says you are at the canary point.
Yeah, it's kind of funny.
So I'm going to tell you.
All right.
So obviously there's no canary because this is the first one, but it's going to be clear when I finish this first one, do another rollout, why that's the case. So I'm going to switch over to the view of my cluster. And here we go. I have a 4-minute deployment. Here's my pod. It's up and running. Perfect. We're happy about that. So just to make sure that it is actually running correctly, make this nice and big. And then I'm just going to test it. I'm going to I think this is working. What did I call it? It's going to be the name of the branch. So feature dash health z endpoint dot hello dot dev dot mycujoo.tv, which did not work. Okay, let's see why. Is our ingress running? Our ingress is running. Is our service running?
It's hello world feature.
Hello world. That's the name of the project. The question is, what did I call the ingress domain? I called it feature. Let's see. Oh, I obviously forgot to actually call this the host. There we go. Yeah. So when I curl directly into the cluster, there's something, in this case it's Nginx, which is listening to all the incoming traffic to look at the host headers and decide which services to send that traffic to. So if I don't include the host header, it says, I don't know where to send that. So when I do include the host header, because we set up that ingress rule, which said for this domain, got that traffic there, we're good. So that's working great. I'm really happy about it. It started up, so I'm going to say, yeah, let's proceed. Everything's working. So the other thing it's done now is it's tagged the release that we made with kubedeploy is live. So if we inspect our cluster, and we go and look at the deployments, let me make this bigger actually. You now see, well, now that I've made it bigger, you can't see. Labels, there's the application name, and here's kubedeploy is live. So we can see if we had, for example, many of these deployments in a cluster, we can see immediately which one is actually live. Now, what I'm going to do is I'm going to update this. I'm going to keep, obviously, our code is living, it's in flux, it's changing all the time. So let me develop this awesome feature. I've been asked to add a health C endpoint. So I'm going to say app.get / health Z. And then I'm going to say, this is going to be incredibly complete. There we go. That's how it works, right? That's how health checks work. So, now that I've done that, and I'm going to commit, which will give me a new hash. Okay. So now that we've got a new hash, we can roll out again. No, this is again because of the this is because I'm in the wrong Docker socket. So let me do the build from here. What? Oh, it's because I messed with this when I was demonstrating. Yeah, I'm not logged into eu.g. Let me go back and see if I can actually.
I wonder how you would.
There we go. So now it's going to do the build automatically. I chose start rollout, I think, right? Yeah. So I'm going to do the rollout directly. I'm not going to build and then do the rollout. But because there's no existing image on the remote, we're just going to go straight for it. So once we have made the build, it's going to deploy. Well, it's going to run the test first, and then it's going to prompt me. And then it's going to deploy an updated, well, it's going to create a new deployment. So we're going to have two separate groups of application containers. But we're going to have one set, or not one set, we're going to have one service. So one way that the traffic is coming in for that host. That allows us to do sort of the A/B balancing, the blue-green balancing. There we go. I was just thinking, I forgot to test if this actually worked, but no, I did. It ran the test. So I know that it does start. There we go. So if we look at what just flew past, so we created a new deployment, and the deployment name includes the branch and also the hash. So this means that the old deployment still exists. So our old copy of the application is still running, but the ingress and the service are unchanged. And now it says we are at a canary point. I'm going to show you what this looks like. So if I go to my cluster, you see I now have 2. Can I go to deployments and see them without it zoomed in? No. I know it's really, really small now. Actually, can I just? No, I can't. But you see I've now got 2, and they only differ in that little hash at the end. I'm going to zoom back in. Now, if I go to my service, remember the service is the thing which does the port translation and sort of accepts all the incoming traffic and does its own internal load balancing and does its round robin. If I go to the service, I'm going to see instead of just having 1 pod, which is serving traffic, I now have 2. These pods are serving different versions of the application. So, if I do this curl again, but now I'm going to do, well, if I curl, I should be able to curl over and over, and that's always exactly the same. But if I curl /health z, I'm going to have, is that what I called the route?
Yeah.
I'm going to have a 50% chance
That it works.
that it'll work. So there we go. Doesn't work. Does work.
Yeah.
Doesn't work. Does work. This is the best canary ever. It's done exactly what I wanted, which is taking a percentage of the traffic. Now, if I was rolling out more than 1 pod at a time, say for example, I had a case where if this was in production, I have 10 production pods instead of just 1. This means instead of receiving half of the traffic, at the moment it would be receiving 1/11 of the production traffic. So that is enough to kind of the whole point of the canary, right? To early flag if the new code is causing a huge problem. So the next step, I'm going to proceed. The next step is we're going to scale. Because it's only 1 and 1, we skipped a step. If it was 10, what would happen next is the new code would be scaled up to 10. So now instead of getting 1/11 of the traffic, it'd be getting 50%. So we got 50/50. Then the next step after that is to scale down the old one, leaving only the new code with all of the traffic, which is actually where we are already here. So it says we've scaled down the old deployment, leaving only the new deployment. Let's go back and see what that looks like in our cluster. So if I go to my deployments, you see the old one is now at 0 pods, and the new one is still at 1. So now I should be able to get a 100% hit rate on my amazing health check, which is looking good. And if I check in the service, I now have just that 1 pod responding. So this looks good. I'm going to proceed. But I came back. So generally we want to wait for a few minutes. We didn't wait for 5 minutes. I'm being a bit risky. I'm willing to test in prod here. So I'm going to proceed anyway. Now if we go back and look at these deployments, they've now got some more interesting labels. So if I look at this new one, this one now has kube-deploy is live. So we've swapped the label over so we can now identify which one is live. But the old one is still there. And there's a reason why. The old one is still there because we want to mark it as our rollback target. Now, if we leave this running for a little while and we find out that actually, shit, this new code is totally broken, we want to revert really quickly, instantaneously. All I have to do is kube-deploy, rollback, and instantaneously, it's rolled up the old deployment back to 1 and kept the other one as it is, so that we can check whether our rollback is actually going to fix the issue. So I decided, I don't like this new health check endpoint. I don't want it there anymore. Let me check whether this has now fixed the issue. Yes. Now 50% of my traffic is fixed because I don't want this endpoint to exist. That's looking good. So let me proceed. It's going to warn me again because I'm being a bad boy. So now if we go back and check, the newer deployment is going to come down to 0, and the old one is still at 1. And if we look at the labels, we've now actually swapped. So the newer is now marked the rollback target. So if I roll back again, it's going to flip back to the newer one.
Okay.
Is that what you were going to ask?
No,
Okay.
no. But did you scale the application? Did you somehow schedule it for how many instances of the application would run? Or?
When I did the rollback just now?
No, in the beginning.
In the
Scale
beginning.
it.
So
Scale it.
that's
But at the canary point, you have not really instances, but two applications running.
let me
So-
make this a bit more clear. I'm going to change this from 1 to 3. So now in development, I'm going to make sure I always have 3 replicas. And I'm going to, where am I? Yeah, I can do this now. So if I decide I'm done and I want to delete, I hope this works, this is a new feature. I'm going to clean up and delete everything. So now I'm going to roll out again. But instead I'm going to spin up 3 replicas. This is configured here in my sort of state configuration. This is the place where I have all these environment variables that end up in the templates. This is because if I look at the Kubernetes configuration of my deployment, this is where we're in YAML hell. Under spec replicas, I mark the replica count here. This allows me to, using the same Kubernetes configuration file, change how many replicas I have in the different environments. But I don't have to change anything in the configuration. So basically anything that is in one of my development branches will now have 3 replicas.
Mm-hmm.
So let's see, so we should check now. We should have 1 pod running. Yeah, this is the old one. But from our new one, we have 1 pod running. So I'm going to say, yes, we're good with that. And now it's going to scale up to 3. So now we're at our kind of full capacity of 3. And let's proceed. And we get a crash. Oh well. I think it's because we had the... Yeah, it was concurrent changes. That's still an open bug. Anyway, if I want to roll forward again, so let me go here and I'll change it. So now I'm going to roll forward. So now what's going to happen is when the new one starts to come up, it's going to go to 1 first. So we're going to have a total of 4 pods in the load balancer, 1/4 of which is the new. And then it's going to scale up to 3. So we're going to have 6 pods. I can't hold up the right number of fingers.
No.
Am I doing it? 6 pods. And so we'll have 50% of the traffic on the new stuff. And then it's going to scale down the old ones.
Okay, but what is, you say you have 4, but you have configured 3. And
so I'm gonna have.
So what is controlling the canary point?
Let me show you. So kube-deploy itself is controlling the canary point. Kube-deploy is saying,
okay.
I know you want 3 eventually, but I'm only going to give you 1 first.
Okay.
So now if we go to the service, we should see a total of 4, I hope. Only 3. Why? Because the old one got canned. Is that right? Oh no, sorry, I'm rolling out yet. I was still in the build step. It prompted me for a Y, and I assumed that it was at a canary point. No, it was still building. But yes, because it's going to have the 3 pods of the old one, plus 1 pod of the new one. Yeah, sorry, that part might not have been clear. Kube-deploy overrides however many pods you said you wanted, and only gives you 1 first.
Okay.
To make sure that that one will start. Problem is, if instead of, see, because the application crashed, it didn't clean up the lock file, so it still thinks something is broken. So let me just unlock to say, yeah, I know I fixed it, and I can go ahead. That's how fixing stuff works, right? I could also have added -- force, but don't tell anybody.
Oh, you actually implemented that.
Of course, gotta have -- force.
Yeah. Because you know what you're doing.
So now I have 5? Oh yeah, one crashed. Why did it crash? I don't know.
Because
Oh, that's not good. Did it come up eventually? Yeah, it came up eventually. I don't know why that was. Yeah, so we now have 4 running pods in the load balancer, right? So 3 of the old ones, 1 of the new one. So that's how our round robin is working.
trying to draw that graph of how many pods you're gonna have at the same time. So are you gonna have 6 in total at some point?
Right now.
So you scale up the new one.
Let me refresh now. So I should have 6 now.
Yeah.
There we go. Now I've got
Yeah,
6.
I was thinking in terms of cluster capacity. So you need to keep in mind that you're gonna
Yeah.
scale that thing to the double amount.
So a lot of our developers are used to blue-green.
Yeah.
The problem with blue-green is it is always twice as expensive. The nice thing about this is it is sometimes twice as expensive.
Yeah.
So you do have to have some extra cluster capacity, but you only have to have a small amount of burst capacity. And if you're not doing that many deployments at the same time, as long as basically you don't have your 2 biggest applications deploy at the same time, for example, maybe that's a bit of a gamble there. But that sort of comes from the blue-green features that we want to be able to have both and then be able to switch backwards.
Yeah, and then you're doing video streaming, of course. So if your new version is maybe performing only 10% of what it should do,
Yeah,
and you would already start to scale down the previous version,
yeah.
you might start to suck very quickly in terms of performance.
Yeah, so hopefully that's why we're still working on some of our monitoring capacity. But the nice thing about this is if we were doing like logging and monitoring based on the application name, based on the release name, which in this case includes the version, the branch, and the hash, then we can look at our graph and see, okay, we had 1 and then nothing, and now we've got 50-50 on all our traffic, but our performance is starting to dip.
Yeah.
That's why it makes you wait 5 minutes.
You have to do that yourself. It's waiting
Yeah,
for
exactly.
slow-
Yeah, it's
for human slowness.
yeah. So the reason that it says now let's wait for 5 minutes, watch the monitors, and let everything simmer is to make you, the developer, check to make sure that your code is actually working the way you expect it should. It doesn't say, do you have monitors? It says, watch the monitors.
Yeah.
So assuming that that's something that's in place enough to be able to rely on. Yeah.
It's verse. The way it's written, like the way it comes across, is quite friendly.
I'm glad you say that.
Yeah.
It comes from a lot of the UI of this is inspired by the deployment tool I worked with when I was at Booking.com, which is a similar kind of flow for doing rollouts and deployments, but much more for kind of old-fashioned on-premises, own data center infrastructure. Yeah.
That he's Canadian.
Yeah, maybe it's friendly Canadian.
Yeah.
Question though, because we briefly touched upon it that you might need have burst capacity requirements.
Yeah.
So is it easy to also scale the underlying capacity of the cluster itself?
Depends on how you run a Kubernetes cluster. We run ours in Google Cloud with the GKE, the managed Google Cloud service. So in that case, it's very easy. If I want to scale, I just change one number in the UI from 4 to 10 to 20 to 100, and all I have to do is pay for it.
Yeah.
There is some auto-scaling stuff in some of these managed services. It's not super fast, so in my experience, if your cluster runs out of capacity, you're going to notice it quicker than the cluster can automatically scale up.
Yeah, we had that before.
Yeah,
Where-
so basically in this case you probably want to know that, okay, if we're going to really do those 2 big applications at the same time, probably maybe add a few more nodes, then do up the process when everything's good, scale back down.
We do have like horizontal pod autoscalers in place for production environments, which actually
That's pod level, and I think you're talking about the actual cluster level.
yeah,
right?
the nodes, but
That's
the
a feature that exists, but it's not great. But I'd say if you're running, if we have 10 different applications running on this cluster, if we're running within a percentage where having double of one of those applications puts us over capacity, then we don't have enough capacity in the cluster.
Well, does I mean like we have monitoring on that or?
Yeah, so that's the idea, is that you'd have some kind of, and we do have some cluster level monitoring for our kind of CPU utilization and RAM utilization on the nodes, as well as like pod level. So to see, if we have a big spike, well, which container is it associated with? That kind of thing.
Yeah. So for node autoscaling, that GCP now has for their Kubernetes engine this node autoscaling feature. It's in beta, I think, or alpha. But you can hook it up with like stack driving metrics or some other metrics to and set that toleration very low. So when you see like when it sees that your nodes are running out of resources or even reserved resources, because you can reserve certain resources for an application, then it can already preemptively, before rolling out all those deployments, instantiate a new node.
But yeah, that's sort of an infrastructure level requirement, and this is very much an application level tool. If you know what I mean, yeah. I assume there's some sort of equivalent feature in AWS to autoscale a group based on.
Yeah, I've seen several things in Azure, but then, as you said, it's just like a little bit after the fact. And if you're going to scale up like this, then you're going to have a problem with your cluster while you're trying to figure out if the canary is good, and then you're going to have conflicting things.
Yeah.
Because then you're testing two things: your capacity of your cluster and the canary.
It's always a gamble, right? Like if it happens when there's a big bug in production and you really need to roll forward and you don't have the capacity to roll forward, and you just kind of have to hope that doesn't occur at the time when your cluster's out of capacity. And the way to fix it is to spend twice as much money and have a much bigger cluster, right? So it's a gamble either way. That's the balance.
Yeah. But if cost is an objection, there are measures.
Just curious.
Yeah. Yeah.
At this point, nobody else can deploy the application.
Nobody else can deploy the application from the same host where I'm running. So, because it's writing a local log file. So because any developers who are not sort of cluster admins would need to go onto the deployment server where these tools are pre-installed for them, then no two developers could do that on the same box at the same time. It's sort of like a deploy server. Now, could a cluster admin come in and override this? Yeah, but that's also kind of the point. And the kind of tying this back to CI and CD, all of this I can maybe show you at some point one of our simpler projects that we actually run, what the CircleCI configuration looks like. But it's basically install this tool and run these commands. It's exactly the same thing as I've done manually. The issue is then, if CircleCI is running, then a developer can also do the same thing at the same time. We've mitigated this almost entirely by having everything run in CircleCI. So that means that developers, all they have to do is push to their branch. So the majority of developers actually never see this tool, never know it exists. It just makes their life easier because deploys happen to every branch automatically all the time. It mostly exists to make the lives of admins easier when we need manual tools or we need to better understand what our CI is doing and to be able to have a way of doing things which is not so specifically tied to one CI. Yeah?
So if you do a production deploy, I assume you're not doing that during prime time.
So because we use Git to manage all of this workflow, when we merge features into master, we automatically get a staging rollout. When we merge from master onto the production branch, we automatically get a production rollout. Okay. So that it's up to any of the developers with kind of admin access to the repo when they decide to merge things onto production. So it's I guess if a brave developer could do that at midnight if they wanted, but they could do that by using the tool manually. They could do it by merging. That's kind of from our CI configuration.
So you don't have bad experiences deploying at the peak of your demand.
We have a lot of different applications. Because Kubernetes is still fairly new, like Stefan was explaining, we have a very different infrastructure before. The majority of our applications that are running in Kubernetes are not high risk. So for the most part, they're sort of like features that support the functionality of the application, but not kind of the core business of the video streaming.
Except now the API is kind of...
Yeah, so we have our primary API is very important to the functionality of the kind of the whole platform. But the video streaming doesn't run in Kubernetes. So if we roll out, we're not going to interrupt a video stream. For example.
Yes, because we're kind of building it.
Someday maybe.
But it's a toughie. Because
Yes.
Kubernetes is not meant for video streaming. I can tell you this. And it's very hard to do so. You have to break your head. It's not fun. Well, it is fun.
But if the rollout is to production, you have to the canary point, do you also have a canary point, or you don't?
We always have a canary point, but in CI and CD, obviously nobody's pressing Y.
No.
So I can actually, yeah, I can show
Do
you.
you
I
have
can
a
show you.
You have a -y option.
Do you have some tests
Yes, we
running
effectively
that-
have. I think it's no canary.
Ugh.
If I do like this, and it's going to roll out and just do kind of the equivalent of -y at all the canary points, which sounds risky, but what is actually really nice is if it fails to scale up the first pod, we find out from CircleCI that it failed at that point. So we still know at which point it failed. So we still kind of get some canary to it because we just don't get the kind of manual canary of actually looking to see if the traffic is okay and watching our monitors. All we get is, do the pods actually start? So if for example, someone pushes a broken build and the pod won't start, well then kube-deploy running in CircleCI is going to fail at that first one pod. And then it's going to be blocked. We're going to get the email from Circle that says, "Uh-oh, somebody broke something." And then we can go and look at the logs and see, okay, it failed at the first one, or it failed when it tried to scale up from 1 to 3.
And do you have some performance testing running or monitoring running?
For
If the pod, if the pod that's not so good deploys and runs, but performance is really bad, do you have performance?
we don't have any kind of automated rolling back in that kind of case.
Okay.
That would be awesome. I guess that
Yeah.
would be sort of something that wraps around the way this works in our CI pipeline. But this is sort of something that enables the CI part to be a little bit easier. That's why I think it's an interesting complement to the first talk, because it sort of picks up and fills in the gaps with that the first talk kind of surrounded. Like, you could combine everything you've learned tonight and do all this, write your GitLab config to then use this for all the templating and rolling out. So for something like that, it's very interesting. I would love to have that functionality. We're a small team of developers, and we're not doing, like I said, not sort of performance-intensive applications right now. But if we were in that kind of case, yeah, like that would be really cool. Why not?
Well, it's on GitHub, right?
Yeah, absolutely. This is open source.
Open source.
Yeah.
Feel free
Please
to.
contribute.
Yeah,
Very nice.
It's it's an interesting. It's also a. So this is all written in Go for the purpose of
Someone's happy.
For a sort of dual purpose, because obviously a lot of this interfaces with the Kubernetes API. It actually started as a bunch of Perl scripts, like literally just shelling out to different kubectl commands, which is an interesting way to sort of set something up, because Perl makes it so easy to run bash subcommands. So if you have a bunch of commands that you have to run in an order, and you want to sort of turn that into some code, it's very, very easy to do that. The flip side is, as that migrated from a series of bash commands and into a Perl script into Go code, some of the functionality still relies on kubectl, like shelling out to kubectl. So as that's gradually getting replaced with direct interaction with the Kubernetes API, and there's some functionality which requires direct access to the Kubernetes API, like the way that we scale up is actually interfacing directly with Kubernetes. And also it's really my first big project written in Go, so it's also very much a learning project. So as I go on, I'm like, I would really love to be able to refactor this, but it's tied up in way too many places, and so that's kind of a big ongoing project.
Did you write unit tests?
I did not write unit tests. Yeah.
Just say yet.
Yes, I have not and will never yet written unit tests.
It's not a learning curve, but it's gonna pay off.
Yes, I absolutely believe it, and especially because it's part of the culture of Go. For sure, when it's sort of eking into the culture of our Node.js code, but not that much there. And for sure, when I was at Booking.com writing Perl, not at all in the culture there.
Booking runs on Perl.
Everything runs on Perl. You can ask me about that later when I'm not on well, I mean, it's on GitHub. You can help us get started with our unit tests.
Yeah.
Anyway.
I did add a slide with the source code. So.
Yeah? Okay. Let's go back here.
Sneak that in.
Live demo.
Now,
Oh,
you need to
question.
refresh, I guess.
Why? Do I?
Yeah, I think it.
When? Oh, did you literally add it? Oh, you added it while I was running the presentation. Okay.
That's it.
Yeah. Now, I have said for a long time and continue to believe that there are two hard problems in computer science: cache invalidation and naming things. I gotta say that I think naming things is a lot harder.
Oh, yeah.
There was previously an existing tool called kube-deploy, which I did not know until very recently. That was part of the Kubernetes group, but that's now been deprecated. So I don't really feel like I have to change the name of mine, but
Maybe in 2 years.
yeah, exactly. I don't know, someday when.
Now we need to add it to the awesome Kubernetes doc, and we quickly claim it for us, and then
Yeah.
we're good.
I remember these programs that the first line was enable debug, the second line was application name, was a variable.
Yeah.
Management tended to change this
Yeah.
so
you
often.
need to.
Yeah, exactly. Okay, so if there are there any more questions? Or just in general about how our stuff works? Yeah.
One question. I see that you use one cluster for all your environments.
In this case, I did, because I'm testing and I'm using a local cluster. What we actually do in our real infrastructure is we have one cluster for our production, our staging, and our sort of acceptance areas. So everything that needs to be production-like. And that actually lives in a separate Google Cloud project, so we can control access to that very differently. All of the rest, and then, so that's one cluster. And then we have a separate cluster for development, which is sort of a sandbox. So we have a little bit more generous access to that. We don't really care that much about what happens in that cluster. It's sort of it's not very powerful machines. That's where we deploy all of the feature branches and all of the test branches. So they all deploy into that cluster. And so that's sort of where we try out and play around with new things. But because kube-deploy is an application level program, it doesn't really care which cluster you're deploying to. It assumes that you've already logged into the correct cluster. That's why I had to check to make sure I didn't deploy to the wrong place.
Okay.
So that means we actually have a step before we run these commands in CircleCI, which is going to log into the correct cluster.
Okay.
Yeah.
Yeah. The variables like development, staging.
Yeah.
Do you just store them with the code, and when you modify them, they are in some kind of feature branch and they get merged with the rest of the code?
Yeah.
So it depends which branch you check out, which configuration you're going to use to run kube-deploy.
Yes. So if I go back to the deploy.yaml,
Yeah,
this configuration file.
I like
Yeah.
this interaction where you locally change something and it was directly applied.
Yeah.
But it could also be a little bit dangerous.
Yeah. So I guess again, this is sort of why most of it runs in CI. So sort of the trust is if a developer has access from their local to the cluster. This also would be a lot more interesting with RBAC, because RBAC is going to, now I'm basically kube-deploy is a user level program, so it's running with all the permissions that I have. So you see all the different things around namespacing and stuff like that. Well, if I only have access to the development namespace, then I can't start messing with this configuration and deploying to different places, for example.
Yeah. No, that's the beauty of it. It allows you to run it as a user. There's nothing special to set up locally. It allows you to run it in a container in your CI system without doing anything special because it runs as that user. And the rest is just up to, I guess, good operations management, like indeed keeping your production separated and keeping the credentials away from.
Yeah, and I think that comes sort of from its history as a bunch of shell scripts to a Perl script to a proper application, is that it's just a convenience application for a bunch of commands that a user could do. So that's why this sort of differs from Helm and Tiller and that kind of ecosystem of plugins for Kubernetes where you're running something in the cluster, which was a consideration of like, well, should we build this as an application which lives in the cluster and then we query against it or something like that.
API driven.
The problem with that is then the application has to manage authentication and stuff like that. And the sort of simplicity of this is that it runs as you, so it has whatever permissions you have.
Yeah, so Helm uses Tiller. We don't use anything. We just use the Kubernetes API. That's it.
Yeah.
Very elegant and simple.
Yeah. Well, you know, Helm and Tiller have some certain advantages as well, but you know, like this is a good way of doing it. Would just like to add one more note here is that yes, like every other tech company ever, we are hiring DevOps engineers, full stack developers, like doing Node.js and also Go more in the future, I hope. And Android and iOS developers for our broadcast and player apps. If you like football, well, it's not a requirement. I like football. Don't tell my boss. I'm sorry, Kai. So it's not a requirement, but yeah, it helps. Like if you're passionate about it, or in general about like video streaming or just any kind of like cool application development with cool people in teams. There's always a place. That's it. Thank you very much.
Cool. Thanks.